Action.
Hey, okay students, so here's another series parallel circuit. We always work from the furthest point, as long as it makes sense, towards the battery. So the first thing we see are these two. They're in series. Could it be in series with all of these? Absolutely not, because of this part of the circuit. So the first thing is this 2K plus 2K are in series. So 2K plus 2K equals 4K, and circle it. We redraw the circuit with everything except these two. So 22 volts. We didn't do anything with this 10K. We didn't do anything here. We didn't do anything here. That's 6K and 6K. We didn't do anything with this 2K yet. But what we did do is put these two together, so that answer would be in parallel with 2K. Sorry if this is sloppy, my bad. It's 4K. So now what do we see? Well, I see 2K in parallel with 4K. So we do that next step. So 2K in parallel with 4K equals 1.33K ohms, and circle it, because that's how we got this resistor. We redraw it again, 22 volts. We haven't done anything with the 10K yet. We didn't do anything with the 6K or this 6K. But what we did do is put these two together as a parallel circuit, so that answer would go right here. So it'd be 1.33K ohms. The last thing I see, well, almost the last thing I see, is these three are in series. When we put them together, they will be in parallel with the 10K. So 6K plus 1.33K plus 6K equals 13.33K ohms. We circle that. Last but not least, we have 22 volts. We haven't done squat with the 10K yet, so we're going to put that in, 10K. But what we did do is add all these three together, so that answer would be in parallel with this. So we have that here, 13.33K ohms. We have to work this circuit as if we have nothing else. We have to make sure this makes sense. We need to get I total, R total, IR1, IR2. These two currents must add up to I total. So the first thing we do is get R total by doing the parallel combination with 10K and 13.33K. And we should get 5.71K ohms. So in order to get I total, remember E total is 22 volts. E total divided by R total gives us I total. I total is 3.85 milliamps. Make sure you're adding the K's, exponent 3, and the milliamps, exponent -3. So this tells me that 3.85 milliamps comes into the circuit, so these two currents must add up to I total. Those two currents are 2.20 milliamps and 1.65 milliamps. Once this circuit makes sense, so you have I total, these two add up to it. We know that voltage is constant in a parallel circuit, so we can put 22 volts here and 22 volts here. Okay, so now we start going back. The first thing we have circled is this 13.33K ohms. And we say, how did we get this? Well, because there's plus signs, they're in series. So what's constant in a series circuit is current. So we're talking about this. This is the voltage across. This is the current through. This current is going to go back to these three resistors, which are here. to get their voltages, and their voltages must add up to where it came from, which is 22 volts. So we can multiply 1.65 milliamps for this guy, and this guy. Okay, and then when we get their voltages, here we get 9.90 volts. This 6K is going to have the same thing because they're the same resistor. And then we do I times R, and we get 2.19 volt. 2.19 volt. We're almost there. We have to make sure that when we add these three up, that it adds up to where it came from. Okay, so once this makes sense, then we go to the next thing we have circled. Okay, so we have 1.33. This is the voltage across this resistor. This is the current through this resistor. How did we get this resistor? We did the parallel combination. So what's constant in a parallel circuit is the voltage. So this 2.19 volts is coming back here and here, which is here and here. Okay, so we put 2.19 volts here, 2.19 volts here. We have to get their currents, and their currents must add up to where it came from, which is this guy. So they have to add up to 1.65 milliamps. We have 1.097 milliamps here and 548.62 microamps here. We add this plus this before we move on. Make sure that it adds up to this. It does. So once that makes sense, the last thing we have circled is this 4K. How did we get this 4K? We did the series combination. What's constant in a series circuit is current. So from this 4K, we bring back this current of 548.62 microamps. This is the current for this and this because they are in series. And now we have to get their voltages. I times R, I times R. You only have to really do it once because they're the same. So you should have 1.097 volts here and 1.097 volts here. And bam, you're done. Thank Mr. Dawes for videotaping this for me.
Oh, yeah.
Bye.